Welcome to this week's Swarf and Chips. We are here at Citizen UK's Centre of Excellence. We've got a great show lined up for you. We're going to do a tour, we've got cycle time challenges, but also we're going to find the difference between synchronised and simultaneous turning and milling, and also the difference between your fixed head and your sliding head stop machines. Very complicated, but that's what these shows are all about, to get your answers and solutions. Now I'm here with Darren, who is the Deputy Managing Director, and you have just opened this brilliant facility. What was the reason behind it?
Well, it's named as the Citizen Centre of Excellence because it's not just to satisfy the UK market where we need additional capacity for our growing business, but it also supports our growing network of overseas dealers across Europe, Western Europe, Middle East and Africa.
Okay, so locations in the UK, Briley Hill, but you've also got another location as well.
We do, yes. So we still have our UK headquarters based in Watford, and that acts as a regional showroom too. We have a long-standing relationship in this area where actually years gone by it was the home of Miano UK, and it was within walking distance of here. This location actually is nearer more customers than our Watford facility.
Right.
And clearly it's in the middle of the country, so it makes perfect logistical sense.
It does. And it's not far from where I live, so I'm happy. So, right, this part on the table, we are going to do a cycle time challenge on it a little bit later on. But as a business, not everyone sees parts like this and then thinks Citizen.
No, they don't. I would suspect most people watching wouldn't align that size of component with our business. We're more well known for higher volume, smaller term parts, particularly on sliding head machines. But of course, the Miano range of machinery satisfies up to 64 millimetres bar turning, for which that is.
Yeah, because in my mind, I always thought 42. Why did I always think that?
I guess probably because the highest number of machines sold are less than 51 millimetre machines for fixed headstock. So yes, that may be the reason why.
And also, you've got this new LFV technology. I say, is it new? How long has it been out?
Well, I first saw it 6 years ago, and for the UK market, we've been delivering sliding head machines with LFV for 4 years.
Right, and is it air cutting? Because I'd like to know a little bit more about it, because I'm thinking, if it's air cutting the part, do you not then have like almost mountains within the part? What's the technology behind it?
Well, that's not a bad description actually. It is a very technical subject because the functionality involves both the CNC control, the servo drives for the axes, and the spindle drives. And essentially what we're doing is oscillating the cut just 20 microns, so there's not much movement, but it's enough to break the swarf, which is the first design priority, is to break the swarf. The numbers of oscillations per revolution, or numbers of revolutions per oscillation is what we can control. We choose either. And that determines the length of swarf. So straight away we're able to break swarf on any material. In fact, the more exotic, the more difficult to chip, the more effective it is.
Oh, really?
So it means we no longer need high pressure coolant. It means we no longer need to stop the machine to remove swarf. And it's done with precision. The programmer of the machine decides how long the chip they want. They could make it so big or so big, and sometimes there is a desired size of chip because it's easier for the chip conveyor to take it away.
The conveyor, and in turn, keeping the spindles turning, doing your unmanned running. You know, you can fill the chip bin in because it's longer than stringy swarf, safer.
Yes. It has a dramatic effect on productivity. It could be, for some end users, particularly on exotic materials, it could mean they're getting 5 times more productivity purely because of this function. Now, you mentioned air cutting, and you're right to say that because if you're oscillating the cuts, there is an element of air cut where you're not cutting. And that allows more coolant to get on the tool, and you are not cutting at that period. And you produce a face that's no longer flat. So you might ask, well, how does that work?
Yes.
Well, here's the really technical part. It is difficult to describe. The machine knows where that oscillation took place. So on the second revolution, it takes away the high spots of that phase.
Right.
And if required on the third revolution, it will finish
it off
almost
as well.
no cut at all. And the end result is we've not just broken the swarf into desired side pieces, but the tool life could be 3, 4, 5, 10 times longer than it was before.
Fantastic.
And we haven't had to remove swarf from the component.
So it's helping in so many different ways, and there's a lot of machines that you can provide and put this technology on. I fancy a little bit of a tour. Should we head over there?
Why not?
Let's go.
Yeah.
So Darren, the first part of the tour, why have you chosen this machine?
Well, it's one of our largest machines, and we need a facility like this to both show a machine like this, but also prepare machines of this nature for end users. And the vast majority of machines this size require a form of turnkey package. Now, everybody's description of turnkey is different, but it's fair to say almost all of them require a level of process engineering designed by us, tooling specified for us, possible automation, and an element of delivery and delivering our goods and services to a contract. So for that we need additional capacity.
So are you basically saying the reason why you've built this facility is for those specific solution, you're providing a solution for everyone?
We are, it's a solution. It's not a machine out of a box, in short. And there's a growing need worldwide actually, but in the UK that's quite evident. Right.
Okay, well, we're going to head over to Colin, who's going to start and kind of finish the rest of the tour, and then when I come back, I'm going to be talking synchronized, superimposed and simultaneous machining. There's a lot to get in there.
Chris, we clobbered you earlier for social media. Thanks for joining us again.
That's all right.
This machine, first of all, L12.
Yeah, super compact, super small, super fast, super accurate, LFB, what else?
Brilliant. And I just want to showcase a component, if you can work the cameraman there. So, thread roll, board, torque, but you can actually, I don't know if the cameraman can actually put 0.2 mil hole in there. Look at that for the camera, working the cameraman to his, no we can't, so anyway, apologies for that people. Moving on swiftly, come on Chris, walk this way. BNE 51, that is bringing a smile to my face as well as Chris's, tell me about it.
Twin turret, twin spindle, but 3 tools in cut, so it's all about the superimposed on this one.
Right, superimposed, so essentially cutting 3 faces in one go.
Yeah, and Mitsubishi.
There you go, nice and easy. Next machine, GTY, there you go.
So this is similar to the B&E, 3 tools in cut, but I don't think there'll be another machine on the market this compact, which will do 42 mil and the same size.
And recently launched with the LFE.
Yes, with LFE as well.
There you go. Right, come on in. I know it's a quick tour, Chris. Keep you fit and healthy. Yeah. Well, neither of the above maybe. L20.
So this is the Type 10 manual B-axis, Y2. It's for machining complex parts really fast.
Okay, I can say the B-axis gives that extra sort of intricacy, if I can say intricacy. Now, I'm going to say to you, Tyvar.
And I'm going to say horrible.
That is a technical term there. So this is L32. Now you have 3 types in a range.
This is the Type 8, no Y2, very basic, entry level 32 mm machine with the LFE, up to 38 mm as well.
But all 3 models, all 3 L32s now have LFE.
Yeah, exactly. And this is the Type 12, which is machining at the moment.
Okay, you can hear it machine at the moment. But modular, so you can add parts.
Yeah, this one's just got the programmable B-axis.
Right. Okay. Now D25, 5-axis. You can make impellers as an example.
Yeah, impellers, anything really.
Okay.
Anything you want surfacing 5-axis, we can do it on here now.
Right. What about the controls and touchscreen?
M800 controller, super fast, really nice to use. Twin gang machine, overlapping, independent Z2, really good.
So you don't hear independent Z2s very often?
No, it's like having a separate head. You don't have to space out tools or anything like that. It's like having another head.
Look at that, the smile on this guy's face, absolutely loving it. So I'm going to have to keep it quick, as we said, Chris. Now, this GN 3200.
Yeah, it's like a near-shaped billet loading machine. Very fast, very accurate, linear rails and slides on there, so sub-micron accuracy.
Okay, so when you say near parts, so they've already been machined, or it might be a casting, for example,
Yeah,
just the final bit.
Like this one is doing the inner race of a bearing.
Okay. And again, micron tolerances.
Yeah, sub-micron.
Sub-micron. Bloody hell. Blimey, sorry, if I can say that on camera. Now, this one, have we got time for this one?
Yeah.
Which is a nice segue into watchmaking parts.
Yep. Yeah, this is RO4, twin gang machine, linear rails and linear slides again, scales, sorry. Really accurate, accurate.
So it's linear
Scales.
Yep, gives you that accuracy. Okay, now this one, I'm thinking sliding head machine, the L20 LFV, which we talked about previously. Where's bar feed?
Well, this one's got a auto loading, so billet work. You know, we can do billet work on sliders as well.
But why would you do that? So I thought the whole point of a slider is having those bars running 24/7.
Sliders are fast as well.
So simple as that. So I'm thinking near finished parts, or maybe tungsten billets.
Yeah, exactly that. You know, material what you only get in billets, or even cycle time driven.
Okay, fair enough. Now, come on. I know we're under a bit of pressure for time. Now the B&J 51, another, well, cracking machine.
Yes. Yeah, this is a
No pressure if you can open the door.
51mm machine, twin spindle, twin turret. This is like your standard twin turret, twin spindle machine. Y2, plenty of power, driven on all stations. Yeah, it's a good machine.
So a great machine, essentially, yeah. And I think we've got 2 more machines to go.
Yep.
So the B&A 42, I'm thinking twin spindle single turret.
Yes, no Y-axis, no superimposed really on here, just a really entry-level machine. Very simple to use, very simple.
Right, okay. And then this B&A 42, any different?
Yes, this one is Mitsubishi. It's similar to the 42S, but this one is all about the superimposed. Right. So you've got X2, Z2 on here, so you can just overlap everything, having 2 heads.
That ties in nicely. So when you say superimposed machining, both spindles working in conjunction, so
on
you
the
can.
same turret.
Yep. Yeah. And so you could do 3 faces or 2 faces on this one.
Faces.
By the machines on the Miana range, 3 faces.
Yeah, that's it.
Okay. Now that ties in nicely because Lindsay's going to learn about simultaneous machining, balance turning, balance milling, pinch milling. The list goes on. If we can educate the girl, and then I'm going to find out a little bit about Swiss machine, sliding head, fixed head. Right, as you probably know, engineers love to confuse me. 5 named for one thing. How am I supposed to learn things and understand it? I've heard today bandied around sliding head, fixed head, Swiss type, guy bush, non-guy bush. Craig, you are the experts. Buy this machine. Educate me, please.
What is it? So this is a Miano B&A 42 GTY LFV machine.
Right, that's confused me straight away, but I'm thinking, as soon as you said Miano, fixed head.
Fixed head, correct. So this is technically a fixed head machine. So with fixed head, we feed out a length of bar, nominally 2.5 times diameter of the diameter of the bar you're machining, and you work on that bar, and your limit is that length.
Right, okay.
Now with this machine, the material is fed out to a fixed stop, but the headstock moves. So it comes under the category of a sliding headstock.
So this one, so fixed head, essentially you're only ever going to work on a length out bar, 2.5 times.
On a length.
Yep.
But because of the configuration, the material moves.
Okay, but this one is actually a hybrid, so the head is actually sliding as well.
Correct.
All right, so that's your fixed head sort of hybrid. I think it'd be opportunity to go and have a look at sliding head, and we can also discuss guide bush, non-guide bush.
So now we've moved over to the Citizen Syncom L32 Type 12 LFV machine.
Easy for you to say.
So this is now a sliding head machine, but because we've got the guide bush in,
Okay.
it's Swiss type technology, which means we're feeding the material through a guide bush.
Right.
So in essence, we can we clamp the material in the collet.
Okay. So the collet's parked away in the back
Parked
here,
away in the back.
and that's essentially the same as on the other machine.
Yeah. But we can feed much longer lengths. Because the material is fed through a rotary guide bush, it supports the material, and the cutting tools are basically positioned really close to the guide bush, less than 1 millimetre. So we don't get any deflection. And what this means, in theory, we could feed material into the machine, and we could turn an infinite length of bar.
Right, so there's no limitation in terms of 2.5?
limitations, because the rigidity is at the guide bush.
Okay.
Whereas again, if you try to do that on a fixed head machine,
Yep.
if you're machining, let's say, a metre away from the clamping point, it's just going to vibrate and bend.
Of course. Okay. Now, final bit then, non-guide bush.
Right, so again, this machine, as with all our products, we can remove the guide bush. So then technically we go back to the setup of the GTY. We're still limited to 2.5 times the diameter of the bar as a guide. But then the headstock, we remove the guide bush housing, the headstock comes forward, and then we can use it like a fixed head machine.
Okay.
But it's still a sliding headstock.
Right. And I presume there's benefits to each type of thing, application specific.
Exactly. So usually you go to non-guide bush, you tend to get a shorter bar end with non-guide bush, so for high value materials, less scrap, and you tend to get better roundness with non-guide bush.
Craig, that's brilliant. It has helped me, actually educate me, which is surprising to everybody I know. And I think more of a challenge, we're going to go and educate Lindsay, and then back to me, I'm going to do some cycle time challenges.
So I'm with Isaac now. We're going to have a little bit of an education on the BNE 51 MSY. We're going to talk balanced turning, superimposed and synchronized machining. Let's start. Balanced turning, machining. What does that mean in regards to this machine?
So in the context of this machine, that would be any operation that we're going to perform an identical operation from the top and the bottom turret at the same time. Okay, so this is going to halve our cycle time by doubling the metal removal rate and also balance out the cutting load, so we're going to be much more stable.
Right, and then synchronized machining. I'm hearing a lot of people talking about it, but does it mean anything particularly specific?
So synchronized machining is where we have the motion of one control group synchronized to the other. So if we move one, the other will move together, and this would be typically used for balance turning, balance milling operations.
With regards to that, does it have to be the same tooling, or what are the specifics in there? Because it's moving together, but does it have to be driven tooling and something top and the bottom are different? I don't know.
So for balance, for pinch work, yes, it would be the same operation, the same tooling.
Okay.
It's exactly mirrored. If you're thinking of superimposed machining, that's then different.
Okay, that's the next one then. Thank you. So what's superimposed machining?
So superimposed machining starts off in a similar way and will overlay the motion of another axis control group onto a tooling area. So in this case it would be a turret and the subspindle. But instead of just being synchronized so they move together, we can also overlay a secondary motion on the second control group, and that allows us to do two simultaneous cutting operations superimposed, but only using one tooling area. So in this case it would give us the ability to use two tools on one turret,
Right.
superimposed, while also using a third tool from the bottom turret, so we got our three tools in the cut.
So you've got three tools cutting that part at the same time.
Exactly.
What does that do to benefit the customer?
So it reduces your cycle time, simple as that.
There you go. There we have it. Isaac, thank you so much. Very intelligent. Right, time now to do your cycle time challenge, but there's a little twist in this one because we've got 4 cycle time challenges, and for you to win the Swarf and Chips goodie bag, you need to get the time of each one added on together. Put that answer in the comments box below and you too could be winning a Swarf and Chips goodie bag.
So, first one of our cycle time challenge. I was going to do it on my own, but Lindsay said they needed some glamour. You could do it anyway. Right, so we're on Citizen L12 with LFE, so process security, no operator intervention. It's not machine review, it's about the component. Where is it? Tiny part. As you'd expect on an L12, so 12mm bar. But looking at that, that is threaded. In fact, it is thread rolled, I was confidently told, and it's got a Torx at the end. Our cameraman has to work him hard. Now, I'm going to have to, down there, tiny bore. But you've also got, I'm tickling you there, Lindsay.
Correct.
On the sides, small, I'd call them slots, but what you probably can't pick up with the camera is 0.2mm holes going in, cut it through there into the bore. So really intricate part, piece of ease. You were worried about what I was going to say there, weren't you? For this machine. How long has it taken? Cycle time challenge. Next cycle time challenge is on the ABX 64. I will describe it as a beast of a machine. It's not often that you see these in machine showrooms because they're such huge machines and in such great demand. This one, twin spindle, triple turret. You can have the twin turret if you want to, but as I said, real powerful, really rigid machine. And the components, well, again, she's got to get in on the act. Loving it. At the moment, the machine is actually pinch milling in the background, but it's doing this part of the job here. So you've got slotted, well, threaded there, bored through the centre, milled, flats, etc. on EN8, I'm reliably informed. Very, well, you're making it look heavy, Lindsay.
So heavy.
How long has it taken to machine this component?
You hold it. Oh, see, I told you.
B&E 51, as you expect, 51 mil diameter bar, twin spindle, twin turret, Y-axis on the main turret. Now, this is a beast of a machine. Again, box sideways, so it's exceptionally rigid. Mitsubishi controls, if I can say that. So really fast and simple to use. Component this time heavier than one of the previous ones that Lindsay was holding. In you come. I despair. Thank God the component's a decent one. Never in doubt. So, grooved, cross-drilled, threaded, milled flat. Come on, work this. Come on, work, Lindsay. Bored through the centre. A lot of material removal there. A lot of material removal there. And etched on the side. Now, not even using the Y-axis on this to do that etching. So, pretty good work there, I'd say. How many seconds, minutes did it take to machine this component? Right, I've managed to escape Lindsay for a second, so I'm going to showcase this component here. So it's being modelled properly this time. We're with the bank of L32s here. You've got three types, L32, 8, 10, 12. The Type 8 has already got LFV, low frequency vibration, but they now have it on a Type 10 and Type 12. That gives you process security, reduced operator intervention, so essentially you can run 24/7, lights out machining, and this machine is doing a cracking job on this component. It's actually made of a material called Tyvar. Now, as you can see, slotted, milled at the end, a little bit boring there, threaded, and a little bit boring in the end there. So that's made out of Tyvar, but the main thing is, with the LFV, you're not getting that big stringy swarf melting onto your spindle. So, cycle time for this one, please.
And don't forget to add up all of the cycle time challenges and you can win a Swarf and Chips goodie bag. Now, this building isn't just about those machines. Upstairs, they've got an auditorium where they can hold sales conferences, and getting people together is the most important thing here. So inside here is the atrium. That's where a lot of their partners are. And these areas are like drop-in centres for their partners. This is so people can be talking, discussing the solutions. So it is welcome for so many people to come along, have a coffee and have a chat. You've got Citizen Finance in the backdrop as well. As we turn around, we're going to head over into the showroom where I can see Colin. I think he's having a coffee now. Oh, I'm done.
Take your time.
I know. Where's my drink?
I don't know.
This is how I get treated.
Get over it, princess.
Yeah.
Anyway, you've learnt loads. Actually, so have I. What have you learned?
I've learned about, well, Darren spoke to me earlier about the LFV,
Yep.
which I find really interesting about the oscillating and getting a smooth finish.
Yep.
And of course, with the Swarf, and you can actually control the size of the Swarf that goes in the bins, which is just bonkers. Also about the superimposing. Look, I worked with Citizen quite a long time ago, and I thought the bar only went up to 42, but it doesn't. It's 64 now.
Absolutely, through bar feed, and they can
Yeah.
get bigger on the chucks, obviously.
And just how they've evolved, cutting with three tools at one time.
Superimposed, as we
Exactly.
now know. And I
Yeah.
learned in terms of Swiss, sliding head, fixed head, superimposed, not superimposed, you've done that one.
Yeah.
The hybrid, guide bush, non-guide bush, and Craig was an absolute legend on that.
Yeah,
Absolute legend.
it's been a good day.
And cycle time challenge is phenomenal. But I just want to clarify, as I said, all four together, which you've already mentioned, but materials, EN8,
Yep.
316, Tyvar, and EN8.
Yes,
There
all
you
added
go.
together as
all
well.
added together. And what do you get? Cycle time challenge winner.
Exactly, and we give out a Swarf and Chips goodie bag every single week, so just comment below, it's free to do it and it's great. And you get a cap and all sorts. Anyway, thank you so much for watching this show, it's been great. Do get in touch with Citizen regarding any purchases, or if you just want some help in regarding how to machine a part. It's what it's all about,
Well,
getting people
just
together.
Go in and see them and they'll help you out, absolutely.
Yeah, well, okay, so thank you so much for watching this week's Swarf and Chips. Don't forget to like, comment and subscribe. And Colin, as we always say, keep those spindles turning.